Hi everyone, it's Mrs. Hoover and Ted with our very first online chemistry lesson, so bear with us. Put him down. So I am picking up with Unit 10, page 6, where we left off. I'm going to try to just teach the stuff you absolutely have to know and then give you like 10 practice questions, not too many so you're not overwhelmed. So here we go. So it's Unit 10, page 6. We're talking about concentration. And we're only going to talk about molarity and parts per million, and the rest you're going to skip. So it does say I'm going to post the key, and it gives the answers, and it also tells you the parts that you need to skip. So concentration is like how strong is my lemonade? Like, is it super concentrated or is it like really watered down? And that's what the word concentration means. So we say if it's really strong lemonade, like with tons of solute in it, it's going to be concentrated. And if it's really watered down and diluted, we call it dilute. All right. And there's two ways to calculate how concentrated something is. And the first one is parts per million. And that's how we figure out like how much lead is in the Shen water, which we recently failed. So now that's why we don't drink certain water in the school, only like filtered water. Instead of doing like, it's a really small amount. So instead of doing like parts per 100, like percent, we're saying, all right, well, there's not that much in the water. So we'll do how many parts out of a million are lead in the water. And sometimes they even do parts per billion. So how many parts out of a billion? So the formula is like all the other formulas in the back of the reference table. And it's just what you'd think it would be. It's how many parts per million are how much stuff, how much of the solute is in how much solution, like how dilute is it? How much of the stuff is divided into how much solution? Is there tons of lemonade mix and only a little water? Or is there only a little lemonade mix and like a ton of water, so it's really dilute? And then just like percents, you always times by 100. This you're going to times by a million. So that's the formula. This is a million, a 1 with 6 zeros. All right, so that is our formula, and I will do the one example problem from the notes, and it says, what's the concentration of a solution prepared by dissolving 25 grams of KNO3 in 100 milliliters of water? All right, well, the mass of the solute is apparently 25 grams, and the mass of the whole solution, I can hear my husband yelling at my kids, is 100 plus. So this is where you might think that it's just the 100 mils. Oh, shoot. I read the wrong problem. Oh, sorry. I don't want to start the video over again. So I read the problem that you skipped, so I'm going to go over the other problem. It says about 0.0047 grams of ammonia are dissolved in 20 grams of water. Express this in parts per million. So the mass of the solute is 0.0047 grams of solute. And the mass of the solution, you might think, oh, that's the 20 grams. But that would be if you're doing the mass of just the solvent. It's not solute over solvent, it's solute over the whole solution. So included in that solution is the solute, so it'd be 0.0047. So that's what's going to go on the bottom. All right, and then times a million. All right, so I'll do this calculation, and I want to kill my husband right now because he's screaming at the kids when I told him that I was doing a video in here, but whatever. So this 20 plus 0.0047 is 20.0047. When I add that up, 0.0047 divided by 20.0047 is some 0.00 number times a million, comes out to be 234.9, we'll round it. And the unit for this is, just like the unit for percent is percent, the unit for this is parts per million. All right, so that's how you do parts per million. It's telling you how concentrated a solution is, how strong is it, and you do it by how much stuff, how much solute is divided amongst how much solution, just like percent is how much of the one thing over the whole total thing, part over whole. So it's the part over the whole, but this time it's times a million instead of times 100%. And you just read the problem, plug in the numbers, make sure that the bottom includes the whole solution. It's not solute over solvent, it's solute over